This lesson is about function arithmetic and the composition of functions. Let's review some definitions. Function arithmetic looks just like you would expect normal arithmetic to look. Given two different functions, such as f of x equals x squared and g of x equals 5x plus 2, you can do all of the following arithmetic operations. You can do addition, f of x plus g of x, which is really x squared plus 5x plus 2, which simplifies to the trinomial x squared plus 5x plus 2. You can do function subtraction, f of x minus g of x, where you do x squared minus 5x plus 2. Make sure you distribute the minus sign to both terms inside the parenthesis, or you might find it helpful to put a 1 in front of the parenthesis so you know you're multiplying everything inside the parenthesis by -1. The result is x squared minus 5x minus 2. You can do function multiplication, f of x times g of x, in which case you have x squared times 5x plus 2. Again, you must distribute the x squared to both terms inside the parenthesis to get 5x cubed plus 2x squared. Yet next you can do division, f of x over g of x. And there's not much to simplify here. It's just x squared over 5x plus 2. Now you could also square a function, like g of x squared. The definition of squaring is multiplying something times itself, so it's really just g of x times g of x, which is another example of function multiplication. In this case, 5x plus 2 times 5x plus 2, you would FOIL those two expressions and result with 25x squared plus 20x plus 4. Last, you could square root a function, such as the square root of f of x. In this case, f of x is x squared, and the square root of x squared, the square root and the square cancel, and it's simply x. These are all examples of function arithmetic. Our next definition, composition of functions. Now this is completely different. Composition of functions is when you actually substitute one function into another function. We use the special notation of a little circle, like this, to mean composition. This first example, f of g of x, meaning you substitute g of x into the f of x function. Or, writing it the other way around, g of f of x, meaning that you're substituting f of x into the g of x function. These two functions are not necessarily equal. F of g of x could be very different than g of f of x. Let's explore our first example. Given the functions f of x equals x squared and g of x equals 5x plus 2, let's evaluate f of g of x, meaning we are going to substitute g of x into f of x, which looks like this. So we want to substitute 5x plus 2 as the input into the function x squared. First, let's write f of x empty, like this. Our function f of x, waiting for the input value, and the formula for f of x is just input squared. Our input will actually be 5x plus 2. So we substitute 5x plus 2 into both sides. F of 5x plus 2, meaning we plug 5x plus 2 into the function something squared. Now we just evaluate. So f of 5x plus 2 is really 5x plus 2 squared. So you write it out as a binomial times a binomial, so you can FOIL the expression, and you get 25x squared plus 20x plus 4. The whole definition of composition looks like this. F of g of x, which means you substitute g of x into f of x, which looks like this, f of 5x plus 2. And so you plug the 5x plus 2 into the function of f, which is really something squared, and then you do all the computations and simplify to get your final answer. What if we substituted f into g? Let's take a look. Note, keep this in mind, substituting f of x into g of x usually yields a different result than substituting g of x into f of x. Recall, in our first result, that f of g of x is the trinomial 25x squared plus 20x plus 4. Now let's go the other way and find g of f of x. We'll use the same functions. Given the functions f of x equals x squared and g of x equals 5x plus 2, let us now substitute f of x into g of x. Thus we are finding g of f of x, which really means we're plugging f of x into g. We want to substitute x squared as the input into the function 5x plus 2. First, write, there's a typo, g of x empty like this. G of input equals 5 times input plus 2. Our input will be x squared, so we substitute x squared into both sides. G of x squared which is really 5 times x squared plus 2. Now we evaluate. G of x squared equals 5 times x squared plus 2, which is simply 5x squared plus 2. The whole definition of composition looks like this. G of f of x, which means you plug f of x into g, and since f of x is x squared, we're plugging x squared in as the input for the g function, which is 5 times x squared plus 2, which simplifies to 5x squared plus 2. Notice we did not get the same answer as f of g of x. We've now calculated both f of g of x and g of f of x, and they were not equal. In the first case, we substituted the function g into the function f, which yielded a trinomial. In the second case, we substituted f into function g, and we received 5x squared plus 2. Let's do one more example of composition of functions. Find f of g of x and g of f of x, given that f of x is the square root of x, and g of x is 3x minus 1. I will write the shorthand now. F of g of x, which means we're plugging g of x into f of x, and since g of x is 3x minus 1, we're plugging 3x minus 1 into function f, which is the square root function, and so our answer is merely the square root of 3x minus 1. On the other hand, g of f of x means we're substituting f of x into g. F of x is the square root of x, and we're plugging that as the input into the g function, which is 3 times the square root of x minus 1, and that simplifies to 3 root x minus 1. Notice again that these two functions are not the same. Here are some practice problems. Complete all of the following function arithmetic and compositions using f of x equals x squared and g of x equals 2x plus 5. Go to the next screen to take a look at your answer key.